In this video, we're going to look at some transistor circuits. For each one, we're going to want to find the voltage and the current of the emitter, the base, and the collector pins. We're going to be using a common emitter gain, or beta, of 50 for each one, and we're going to assume that the absolute value of the base and emitter voltage is 0.8 volts, and that's going to be independent of the current. So let's get started. So here's our first circuit. Let's start by finding the voltage for the base. We can see from the diagram it's connected to ground. So we can say that the voltage for the base is 0 volts. Because the voltage of the base and emitter is 0.8 volts, we can determine the emitter voltage. We're going to have V sub B minus V sub E is equal to 0.8 volts. VB is 0 minus V sub E, 0.8 volts. So the voltage at the emitter pin, that's this one here, is equal to negative 0.8 volts. So we found VB and VE so far. Next, let's try to find the value of the emitter current. So the emitter current is going to be equal to the emitter voltage minus negative 1.5 volts, and we're going to divide by this resistor here, 2.7 k ohms. That's 2.7 times 10 to the third power ohms. Whoops, I forgot the negative sign here. So we know the value of VE, so we can solve this, and this is going to give us a value of 259.2 microamps. So we have our emitter current, that's checked off. Next, let's find the value of the collector current. So for the collector current, we're going to want to use beta over beta plus 1 times the emitter current. Our beta is 50. We know what our emitter current is, so we're going to get 50 over 50 plus 1 times 259.2 times 10 to the negative 6 amps. That's going to give us about 254.1 microamps. So now we have our currents for the collector. Let's find the voltage. So our voltage at the collector pin is going to be the 1.5 voltage up here minus the current times the resistance. So we have our collector current, and our resistance is this 2.7 k ohm resistor. That should give us about 0.814 volts. Okay, so we found that. Last thing we need to find is the base current. To find our base current, we're going to need the collector current, and we're going to put that over our common emitter gain, beta. So we have 254.1 times 10 to the negative 6 amps over 50, which will give us about 5.08 microamps. There we have it. We solved all 6 of our values. Let's move on to the next problem. So here's our next transistor circuit. Notice in this one that the emitter and the collector pin are switched compared to the last one. So first let's find our base voltage. Pretty easy, it's just going to be 0 volts. Next, let's find the emitter voltage. Again, the absolute value of our base and emitter voltage is going to be 0.8 volts. So voltage of the base minus emitter voltage is equal to 0.8 volts. Actually, scratch that. It's going to be negative 0.8 volts. That's because this is a PNP transistor, And like I said earlier, the emitter and the collector pins are switched. So our emitter voltage value is going to be positive 0.8 volts. So check that off. Now let's find the emitter current. To find that, we're going to need the 1.5 voltage up here minus the emitter voltage, 0.8, and we're going to divide that by this 2K resistor. That should give us a value of about 0.35 milliamps. So we have this. Next, we're going to find the collector current. For this type of transistor, we're going to need beta over beta plus 1 times the emitter current. So that's going to give us 50 over 50 plus 1 times 0.35 times 10 to the negative 3 amps. That's 0.35 milliamps. So that's going to give us a value of about 343.14 microamps. So we can check the collector current off. Now let's find the voltage at the collector pin. So for this one, we're going to take this negative 1.5 voltage, and to that we're going to add the collector current times this 2K resistor. So our collector current is 343.14 times 10 to the negative 6 amps times 2,000 ohms. This is going to give us a value of negative 0.814 volts. So we got our collector voltage. Lastly, let's find our base current. So the base current is going to be equal to the collector current over the common emitter gain. So that'll be 343.14 times 10 to the negative 6 amps over 50. That's going to give us about 6.86 microamps. So that's all of our values. Let's move on to the next one. So here's our next transistor circuit. Let's again first start by finding our base voltage. And here we can see it's positive 1 volt. That was easy. Now let's find the emitter voltage. So again, this is a PNP transistor. The emitter current is coming from the positive voltage value, and the collector is going into ground. So we have the base voltage minus the emitter voltage is equal to negative 0.8 volts. That's just like the last one we did. So base voltage is 1 volt minus VE is equal to negative 0.8 volts minus 1 on both sides. Negative VE is equal to negative 1.8 volts, giving us a emitter voltage of 1.8 volts. Check that off. Now let's find our emitter current. So for that, we're going to want this positive 3 volt source, subtract it from the emitter voltage, 1.8 volts, and we're going to divide by this 10K resistor. That's going to give us 0.12 milliamps. So we have that. Now let's find the collector current. For that, again, we're going to want beta over beta plus 1 times our emitter current, 0.12 times 10 to the negative 3 amps, and our beta is 50. So we have 50 over 50 plus 1 times 0.12 milliamps. That's going to give us a collector current of 0.117 milliamps. Now let's find our collector voltage. Now because we're connected to ground here, it's going to be a little bit more straightforward. Our voltage here is 0, so VC is going to equal to IC times the resistor. So collector voltage is going to be 0.117 milliamps times 5.6 k ohms, which is going to give us a value of 0.655 volts. Now we just have the base current to find. That's going to equal the collector current over beta. So we have 0.117 times 10 to the negative 3 amps over 50. That'll give us a value of 2.34 microamps. We did it again. We found all 6 of our values. Let's do one more problem. So here is our last transistor circuit. Let's start by finding our base voltage, and it's here for us. That's 1.5 volts. For our emitter voltage, we're going to use base voltage minus emitter voltage is 0.8 volts. We have base voltage minus emitter voltage is 0.8. Subtract 1.5 from each side. Negative VE is equal to 0.7 volts negative. So our emitter voltage is 0.7 volts. Now let's find the emitter current. Now for the emitter current, we're going to need the emitter voltage minus 0, and we just put that there because this is connected to ground, which gives us 0 volts, and that's going to be over this 4.7K resistor. That's going to give us a value of 0.149 milliamps. Next, for the collector current, we're going to need beta over beta plus 1 times the emitter current. So that's going to give us 50 over 50 plus 1 times 0.149 times 10 to the negative 3 amps, which is going to be 0.146 milliamps. Now for the voltage at the collector pin, we're going to need the voltage up here, which is positive 3 volts. I don't know why that disappeared. And we're going to subtract the collector current times this 8.2K resistor. So we got 3 volts minus 0.146 milliamps times 8.2 thousand ohms. That'll give us a value of 1.8 volts. Now let's find the base current. That's going to be the collector current over beta. So 0.146 times 10 to the negative 3 amps over 50. And that's going to give us 2.92 microamps. We just found the emitter, base, and collector voltages and currents for 4 transistor circuits. I hope you enjoyed the video. I hope it was helpful, and thank you for watching.